For introduction, the objective of this presentation is to provide an information about hardware tool related to our project, the Paddy Water Level Management System, which is this presentation we will review a few hardware related to this Paddy Water Level Management System that are existing today. Okay, next, please. First is Paddy Watch. Paddy Watch developed by Vegetalia in April 2016. It's equipped with sensor and communication function. The function of this Paddy Watch is check the status of paddy, changing the water level and temperature. There's 4 types of data that to measure by this Paddy Watch. First is water level, water temperature, temperature of the paddy field, and humidity. Next, please. Second is a field server, an agricultural metering system developed for Thailand. It's installed at the observe field for a long period of time. It will install for a long period to catch a data, collect data. There's 2 types of data collected into parts. First, daily image. Second, with information. For daily image, it's accurate twice per day. In with information, it's recorded every 5 minutes, such as temperature, rain volume, electricity, humidity, cell moisture, wind, and direction. This is the image of the field server, and this is the data for the weather information. Example, okay. Third is Teach Rise. Teach Rise is a box sturdy and waterproof that encloses a customized Arduino socket to which are connected sensors to measure temperature, humidity, and water level. It's powered by solar panels, logs data on SD cards, connects to the cloud with 3G, so the farmer can view the paddy field by this cloud. By using the cloud, it's connected to the farmer device. It uses sonar to take measures that are accurate to less than a centimeter without contact. Okay, that's all for the review. Next.
Okay, so I'm going to present about Paddy Water Level Management System proposed for the project. So this project mainly consists of 4 main hardware. So the first one is smartphone or an embedded computer. So smartphone, if you want more versatility, so which means you can monitor the paddy field from anywhere, and then embedded computer is the one that you can only see on the paddy field, can monitor from the paddy field. So the function of this smartphone or embedded computer is it is to monitor the water level of the paddy field. So other than that, it's also used to set the current growth stage of the paddy. So this is because at different growth stage of paddy, different amount of water is needed. So it must be set to what growth stage it is. So for the hardware used, so it is using any smartphone with iOS 8.0 and above, or Android 8.0 and above. So the second hardware is smart drain. So its function is to open the drain when the moisture sensor detects excessive amount of water on the paddy field. So basically the hardware we use is, it consists of PVC pipe with motorized hole that can be triggered from the smartphone if the moisture sensor is failure, or by signal from moisture sensor. So basically it is a custom made PVC pipe which connected by a motorized hole that can be open or closed from the signal or by the smartphone. So next is moisture or humidity sensor. So the use of this sensor is to detect the water level of the paddy field. because as I said before, different growth stage need different amount of water. So the hardware we use is large connectivity centriers, which is a company from Taiwan that use RX1XX series industrial humidity sensor. So for the motor, we use an induction pump motor. So the function is to send water into the field if the water level is too low. Other than that, it's also used to flow water into the water tank if the water level is too much. So for the motor, we're going to use LN Delta three-phase induction motor, which using 0.75 kilowatt, 1 horsepower, and 1440 RPM. So this is the block diagram for the system for the project. So as you can see, the smartphone is connected to the paddy field, which it can monitor the paddy field water level. And then the paddy field is connected to the smart drain, and then the smart drain also connected to the field, so it will open the drain. Uh, and then the smart drain is connected to the water tank, and then the paddy field also connected to the moisture sensor, which is connected to the smart drain and the motor. So the function of the moisture sensor is it will send signal when water level exceed. So it will send signal to smart drain, and then the smart drain will open the drain if the water level is exceed the set amount from the smartphone. So the moisture sensor also sends signal when water level is less. As you can see, it sends signal to the motor, and then the motor will flow the water from the water tank and then into the paddy field. So this is a prototype of the system. As you can see, this is 2 square field of paddy. Two pump induction motor needed to flow water from water tank to the paddy field and vice versa. So as you can see, this is water tank that will flow the water from the paddy field if it's too much, and then it will flow to the water tank, and then and it also will flow from the water tank into the paddy field if the water is too less. So a square paddy field needed minimum 4 open closed motorized hole, so it can flow water from the field. This is minimum, it can be more. So so one moisture sensor is needed at minimum to detect heat moisture, because but it also depend on the surface of the soil. If the surface is not is not stable, it might need 2 or more, because a different place it has different depth. So for the conclusion, hardware tool did play important role in the paddy water level management system, because a lot of tool needed to create the project. Okay, that's all. Thank you.